What's up, guys? It's Miss Muller back telling you some answers on how to solve problems from the Multiplying Fractions Nearpod. So I'm going to go over 3 questions, just the ones that I thought were tricky or could use a little bit of help on. So let's start by looking at number 3. Here we go. Number 3 says, Miss Richardson and her students ran 3/4 of a mile during recess for 4 days. Miss Jamison and her students ran 3/8 of a mile during recess for 5 days. Which class ran farther, and how much farther? All right, in order to come up with which class ran farther, we have to first calculate how much each class ran. So I'm going to switch on over here to my notebook, and let's get started. All right. So this is problem number 3. So we're going to start with figuring out how much Miss Richardson's class has ran. So I'm going to label with Miss Richardson, and I know that her class ran 3/4 of a mile for 4 days. So I'm going to do 4 times 3/4. Now, how I do that is I'm going to draw out my boxes. I'm going to do 4 of them because I'm multiplying times 4, and 3/4 is close to 1 whole. Now I'm going to take each box and divide it into 4 pieces. I'm doing that because I have 3/4 of a mile. That denominator down here is a 4, so that's how I know what to separate my boxes into. Now, up on top of my numerator, I have a 3. So that means I'm going to write each number 3 times, and because I'm multiplying times 4, that's the number that I'm going to stop at. So starting with 1, I'm going to write 1 3 times. 1, 2, 3. Then I'm going to write a 2 in 3 boxes, then a 3 in 3 boxes, and then a 4 in 4 boxes. Then I stop with that 4 because I was only going up to 4 times. So I look at how many holes do I have. I have 1, 2, 3 holes. So together, her class ran 3 miles. Now the other class was Miss Jamison's class. So we're going to label it Miss Jamison. And her students ran 3/8 of a mile for 5 days. So I'm going to do 5 times 3/8. So I do the same thing. I'm going to set up my boxes. I'm only going to draw 3 because I know that 3/8 is less than half. So I'm only going to be filling in about half of each of these. And now I have to separate all of my boxes into 8 pieces. So I'm going to start by doing 4. Oh, these boxes are going to be small. Sorry, guys. 8. I do 4. Make it 8. And I'm going to do 4. Make it 8. Because I have an 8 on the bottom, 8 in my denominator, so that's why I have to separate each box into 8 equal pieces. I know this one isn't completely equal, but it'll work. And I'm going to write each number 3 times and stop at number 5. So I'm going to write 1, 2, 3, 2, 2, 3, 3, 2, 3, 4, 2, 3, and then stopping at 5. So I get my answer of 1 whole and 1, 2, 3, 4, 5, 6, 7 eighths. 1 whole and 7 eighths. Now when I look back at the problem, it asks me which class ran farther. So I know that Miss Richardson's class ran farther because 3 is greater than 1 and 7 eighths. But then it asks me how much farther. When I'm figuring out how much farther, that's a comparison statement. That wants me to subtract. So I have to do 3 minus 1 and 7 eighths. And the fastest way to do that, you guessed it, a number line. So I start at 1 and 7 eighths. I'm going to go up 1/8 to get me to that next whole number, which is 2. And I'm just going to jump 1 whole to get to 3. So I have 1 whole and 1/8. So 1 and 1/8. That's how much further Miss Richardson's class ran than Miss Jamison's. All right, let's switch over to our next problem. We're going to go to problem number 6. Problem number 6 says, Miss Twitty bought 16 pounds of shrimp for a party. She used 5/8 of the shrimp during a Clemson tailgate party. How many pounds of shrimp did she use? Now, it's important to note here that this is a different type of problem than the last one. The last one was a repeated addition multiplication problem because they are running the same amount over and over and over again. Here, that's not the case. Each person isn't eating 5/8 of a shrimp. We have 16 pounds as a whole, and we're only taking part of it. So when we have a whole, like 16, and we're taking a fractional part of it, that is when we solve it using our fraction of a set method. So this is how I would solve problem number 6. I'm going to write it down here. Problem 6. Now, she has 16 pounds, and she wants to use 5/8 of it. So I have 16 times 5/8. I want to write it as 5/8 times 16 because I really am taking 5/8 of this whole 16. Okay? And so when I'm finding 5/8 of that 16, I start by drawing my bar diagram. And I have to separate it into 8 pieces that are even. There we go. I have 8 even pieces. Now, I have to take 16, because that's my whole, and I'm dividing it into 8 pieces because my denominator is an 8. So when I take 16 and divide it by 8, I know that each box up here is going to have to hold 2. I have 2, 4, 6, 8, 10, 12, 14, 16. So this bar right here represents my whole of 16. And then each one of these is 1/8 of it. So I have 1/8 here, 2/8, 3/8, 4/8, 5/8. So when it asks me, how much did she use when she used 5/8? 1, 2, 3, 4, 5. I'm only looking at these amounts. So I have 2, 4, 6, 8, 10. So 5/8 of 16 is 10. There we go. All right, our last one. We're going to look at problem number 9. Problem number 9 says, what is the perimeter of a square with a side measuring 1 3/4 inches? Now, it uses a vocabulary word that we haven't really talked about a lot this year, but you should have learned last year. The perimeter. Perimeter is just the measure of the length of all the sides on the outside. And something we know about a square is that all sides are congruent. That means they're all equal. So if I'm finding the perimeter of a square, what I'm really doing is multiplying the length of one side times 4. So I'm going to do that. 4 times 1 3/4. Here we go. Problem 9. 4 times 1 3/4. Now, when I'm multiplying a whole number times a mixed number, this is when my area model comes back into play. So I draw my box and separate it like that. My whole number goes over here, so I have 4 times 1, which is my whole over here, and my fraction, and 3/4. In this box, I have 4 times 1, which we all know is 4. And in this box over here, I'm going to write it really small, I have 4 times 3/4. Now, some of y'all have realized that I can just take my whole number and multiply it times my numerator to get my answer that way. So 4 times 3 is equal to 12. So I have 12/4. 12/4. And if I know 12 divided by 4, that gives me 3 wholes. So I would just take 4 plus 3 and get my answer of 7. However, if you didn't know that you could just multiply 4 times 3 and keep it over 4 to get that, you could also do it by doing 4 times 3/4, just like we've practiced before, and draw your boxes. These guys will never fail you. And draw it this way. I have each box divided into 4 parts because 4 is in my denominator. I write each number 3 times. 1, 2, 3. 2, 2, 3. 3, 2, 3. And I stop at the number 4 because it's right here. And so I have 3 wholes here. So that was how I got the answer to this part. So I add 4 plus 3. That gives me 7. And there you go. That's your answer. All right, I hope that was helpful. I'll talk to y'all soon. Bye.